Alright class, it's session number 19 and exercise 16.2, and in today's class we are going to start from question number 1. It says that for each of the following equations connecting x and y, if the rate of change of x is 2 units per second, so what is given actually dx upon dt, that is meant by rate of change of x and its value is 2 units per second. Find the rate of change of y. What you need to find out, you need to find dy upon dt is question mark. Alright, so not a difficult question it is. What is the strategy that I'm going to follow? That first I will explain you the first part and then I will give you second part to do it by yourself. You need to give it a try and then I will tell you the solution of its part. So let's begin with question number 1, part A. It says that y equals to 3x square minus 1 and the value of x is 2. Alright, we need to find out dy by dt, right? But before that we need to find out dy by dx. So dy by dx is equals to 3 2s are 6x, that is the value of dy by dx. The value of x is known, so I can say that dy over dx at x equals to 2 equals to 6 times 2 equals to 12. Right? Fair enough, no confusion, no problem. Alright. Now we need to find out dy upon dt, right? The rate of change of y at given instant. So now there is a rule and we say that it's a chain rule. And what is chain rule basically? It says that dy over dt equals to dy over dx multiplied by dx upon dt. That is a very thin formula, but it varies from question to question. Like if you are solving volume, so volume mostly depends upon radius, right? Area depends on radius, so it might be changed. How? What you need to observe that the variable dx and the variable dx, they must be equal for any case, right? And the leftover part dy upon dt, it is basically equal to your left side. Alright, so to define chain rule, that is very important, right? Similarly, let's suppose if I'm saying that let's suppose df upon dt. So the working formula, it will be df divided by dx and then dx upon dt, right? Take one more. If I say dh upon dt, so here first thing dh upon dx multiplied by dx upon dt. So these two variables, it must be same. These two variables, h depends on x, or any two variables can be given in this form. Like in my case, y depends on x, so that is why I've written dy upon dx, right? Let's suppose if you have area depend on radius, so you will write dA upon dr and vice versa. So that is a chain rule. So up till now we had find out that dy upon dx is 12 units. If I am going to apply the working formula, that dy upon dt equals to dy upon dx multiplied by dx upon dt. So dy by dt we need to find out. Dy upon dx we had find out and its value is 12. Dx upon dt is given in the question, right? Dx upon dt is 2 units per second, so it's 2. So the answer is 12 times 2 is 24, that is dy upon dt. Alright, so I hope that you got minute idea regarding the chain rule. Now listen to me carefully for part B. Question is y is equals to 3x minus 5 power 5 and the value of x is 4 divided by 3. Alright, we know that the working formula or the unknown that we need to find out is dy upon dt, that is the unknown. With respect to chain rule, we know that it is equals to dy upon dx and dx upon dt. That value we have assigned in the question, and that is 2. Now the leftover part is dy upon dx, so I'm going to find out dy by dx here. And the differentiation is quite easy, that first we need to write down the power, then subtract 1 from the power, and then derivate the function which has power, that is 3. Once you got the derivative, now you need to place the value of x. So dy by dx at x equals to 4 divided by 3 is 5. 3 times 4 upon 3 minus 5 power 4 and 3. You need to solve it. 3 and 3 cancels. 5, 4 minus 5 minus 1. Minus 1 to the power 4 is 1 and 3. Alright, so basically it is equals to 15. You got the value of dy by dx. Now you need to just place the value here. So that is equals to 15, and dx upon dt is given 2. So the answer for dy by dt is 30. After I've explained part D, you need to attempt one more part, and let's say you guys attempt part F. Alright, so now you need to attempt part F by yourself in the classwork. So it's y equals to x divided by x plus 1. Y is equals to x divided by x plus 1, and the value of x, I think, is not given. The value of y is given here. Yes, the value of y is 2. The value of y is 2. Now there is one add-on step we need to follow in this question, and that is what? First we need to place the value of y in that question and find x. So that is equals to 2 equals to x divided by x plus 1, cross multiply. 2x plus 2 equals to x, simplify, x equals to minus 2. You got your value of x. Now you need to start differentiation. So there are two functions, x and x plus 1, so you need to apply u upon v. So I'll say that u equals to x, u dash equals to 1, v equals to x plus 1, and v dash equals to 1. Alright, now formula says v derivative of u minus u derivative of v divided by v square. So v is what? V is x plus 1, derivative of u is 1, minus u is x, derivative of v is 1, divided by v square means x plus 1 whole square, and that is what? That is dy upon dx. The value of x and minus is cancelled. The value of x is minus 2, so it leads to 1 divided by minus 2 plus 1 is minus 1 square 1. So dy over dx equals to 1. You got the value of derivative, right? Now we need to find out dy upon dt. The chain rule is simple: dy upon dx multiplied by dx upon dt. So dy upon dx is 1 and dx upon dt we have is 2. So the final answer for this question is 2. It's question number 2. Each of the following equations connecting x and y, if the rate of change of y is 4 units per second. So you need to understand what is given. Rate of change of y, it means that dy upon dt is given and it's 4 units per second. Find the rate of change of x. What you need to find out? Dx upon dt is what you need to find out. So for first part I will tell you how it's done, and you need to try for second part. So a part is y equals to x cube minus 2x square. The value of x is 3. Alright, first you need to derivate it. So dy upon dx equals to 3x square minus 4x. Value of x is known. Dy upon dx at x equals to 3 equals to 3 square 9 3s are 27 minus 3 4s are 12. 27 minus 12 leads to 50. So that is your dy by dx. Applying the chain rule now, dy upon dt equals to dy upon dx multiplied by dx upon dt. What value we have known? dy upon dt is given, it's 4, dy upon dx we had find out 15, and dx upon dt is what we are looking for. So now it's quite easy, you need to make dx upon dt subject, so that will be 4 divided by 15 equals to dx divided by dt, and that is your answer. Simple question it is, you can do it easily, I expect you. Moving on towards the next question, question number 3. Two parts in this question. Alright, now listen to this question carefully. I will start with the first part and I will give the second part. You need to give it a try and then I will explain you. The radius of a circle increases at a rate of 2 centimeter per second. Now what is given in the data? Radius dr at rate of time dt. So dr upon dt is 2 centimeter per second, that is given. Find the rate of increase of its area. What you need to find out? You need to find out rate of increase of area, that means dA upon dt is what we need to find out in both of the parts. For first part, it says that radius is 4. Alright. The shape we have is circle, right? The shape we have is circle. So area of a circle is pi r square. You all know it very well. If you differentiate it, so dA upon dr equals to 2 pi r, right? We have the value of r, that is 4. So dA upon dr at r equals to 4 equals to 2 4s are 8 pi. Alright. Now we have dA upon dr. We need to find dA upon dt with the help of chain rule, and that is dA divided by dt. Now A depends upon r, dA upon dr, and r depends on time. So dr upon dt, and I've told you that these two must be same, and if you cancel it hypothetically, then d upon dt is equals to d upon dt. Alright, so now dA upon dr, it's 8 pi, it's 8 pi into dr upon dt, it's given, it's 2. So dA upon dt, that is equals to 16 pi, unit will be centimeter square per second. Alright, so I hope that it is clear to you. Now for this part, you have a time of 60 seconds to note down the solution in your copy. It says that the area is 9 pi. Now in part A, radius was given, so we have directly used the value of radius. In part B, area is given, so first you need to find out the value of radius. How? Area is what? Area is pi r square, right? Area is known, it's 9 pi equals to pi r square, pi and pi cancel. 9 equals to r square, so r equals to 3. Alright, now you have the value of 3. You need to complete the solution by yourself. A upon dr, we had find out that was 2 pi r, but now the value of r is 3, so that is 12 pi, right? So dA divided by dt, here we are going to apply chain rule, that is dA upon dr times dr upon dt. Alright, so dA upon dr, it's 12 pi, and dr upon dt is given in the question, that is 2. So it's 24 pi centimeter square per second, that is your change of area. But I think there is a mistake. 2 3s are 6, so it's 6 pi, 6 pi, and 6 2s are, so it's 12 pi. That is your answer. All right. So moving on towards the next question, and question is question number 5. It says that the radius of a circular disc increases at a constant rate of 0.02 centimeter per second. What is given? It's dr upon dt is 0.02 centimeter per second, right? Find the rate at which the area is increasing. We need to find out dA upon dt. When the radius is 10, the initial value or the value of radius is 10. Since we are dealing with a circular disc, so area is pi r square. What you need to find out? dA upon dt. You have the chain rule, and that is dA upon dt dA upon dR upon dt. Alright, so for this complete question in which I have mentioned all the necessary details, we need to find out the differentiation of A equals to pi r square. So dA over dr equals to 2 pi r. The value of r is known, it's 10. So that will be 20 pi at dA upon dr when the value of r is 10. That is your first part, right? We have the value of dA upon dr. Dr upon dt, it's already given, that is 0.02. So dA upon dt equals to dA upon dt, we need to find out dA upon dr is 20 pi and dr upon dt is 0.02. So we need to multiply 20 with 0.02, 20 into 0.02. It's 0.4. So dA upon dt it's 0.4, right? And the unit will be centimeter square per second. That is your dA upon dt final answer. All right, moving on towards the next one. That will be the last question of today's session. It's question number 8. All right. Question says air is let out of a spherical balloon at a rate of 300 centimeter cube per second. So what is given? That is dV divided by dt. It's change of volume. 300 centimeter cube per second. Find the rate at which the radius is decreasing when. First part. The radius is 2 centimeter. Alright, so we need to find out the rate of radius, right? So before that, if I apply a chain rule here, so it will be dV upon dt. Now V depends upon radius and radius depends upon time. So that is your chain rule. But the very important thing is you must be aware regarding the working formula of volume of a sphere. So volume of a sphere is 4 divided by 3 pi r cube, right? For dV upon dr, if I am working for dV upon dr, I need to derivate it. So dV divided by dr equals to 4 upon 3 as it is. That function, when you derivate it, only r cube. In fact, 4 upon 3 pi works as a coefficient. Now the derivative of r cube is 3r square, right? You can simplify, 3 and 3 cancels. Leftover part is 4 pi r square. Value of r is known, it's 2. So that will be 4 pi r square. 2 square 4, 4 4s are 16. So dV upon dr equals to 16 pi. That is your first thing we have find out, dV upon dr. Alright, dV upon dt is already given, that is 300 centimeter per cube per second, and now we need to find dr upon dt. So I am just substituting values here. dV upon dt is 300, dV upon dr is 16 pi, and dr upon dt is what we need to find out. Alright, now you need to simplify it. So that will be 300 divided by 16 pi equals to dr upon dt. We can easily solve it. 300 divided by 16 divided by 3.142 pi, that is equals to 5.96 equals to dr upon dt. Alright, clear? For second part, you need to give it a try, but I will tell you just the initial phase. So for second part, since volume is given, we have the working formula. Volume is 4 divided by 3 pi r cube. The value of volume is known, it's 36 pi equals to 4 divided by 3 pi r cube. Now you need to attempt this by yourself, but before that you need to copy down the solution and then start doing for part B. For part B, first we need to find out radius and then follow the same procedure we have attempted in part A. So now first we need to find the value of radius. So pi cancel, 4 1s are 4, 4 9s are 36, 9 3s are 27 equals to r cube. Apply cube root on both sides, so r equals to 3. Right, we have the value of r. Now dv divided by dr, we have find out that was 4 pi r square, right? We had find out this one, 4 pi r square, so we are using 4 pi r square. Instead of r, I'm going to place the value of r, it's 3 now. So 3 square 9, 9 4s are 36 pi, that is your dv upon dr. The working formula chain rule, this one, that is the working formula, right? So now it will be equals to dv divided by dt equals to dv upon dr into dr upon dt. So dv upon dt it's given is 300 equals to dv upon dr, you have to find out 36 pi, and dr upon dt we are looking for. So that will be 300 divided by 36 pi equals to dv upon dt. If you simplify it, so that will be 25 divided by 3 pi equals to dv upon dt, and that is your answer. Alright, so I think that is enough for today class. Inshallah, in next class we are going to continue with the chapter number 16. You need to practice, complete your homework by yourself and submit it on time. Take care. Allah Hafiz.